Hello, Dylan. Hello?
Oh, there you go. Can you hear me?
Yeah, I can hear you now.
Okay, sorry. I had the volume on mute by accident.
Now I do that all the time. I got a little power button on my microphone, and every now and then I'll accidentally touch it.
Yeah.
Of course, then nobody can hear me, and I don't know nobody's hearing me.
Yeah, exactly.
All right, so what are we doing tonight?
Alright, so we're doing just test review.
Okay.
It's like polynomial expressions and equations.
Okay. Is this stuff you can verbalize?
Yeah.
Okay.
Yeah. So the first one is 6 plus 2x squared. And then it says write the polynomial in standard form.
Okay.
So my teacher doesn't really explain this well, so I'm kind of having a hard time.
Put the
understanding
highest
this.
degree polynomial first.
Okay.
That's it.
So 2. Okay.
Okay. If I had, say, that also, then that would need to go before the 6. In other words, minus. That's the way it would look. Just, in other words, line up these. Make sure that the exponents go from big to little, going left to right.
Okay. Okay.
All right.
Cool. Okay. And then, okay, so now it's negative 3p to the third plus 5p to the sixth minus 4.
Okay. What degree polynomial is this?
You can't.
It's a sixth.
Right.
In other words, yeah, the degree of the I know they didn't ask you that, but the degree of the polynomial is the largest exponent.
Okay.
So that's why this is called a quadratic, because the degree of the exponent is 2, the largest.
Okay.
Now, all quadratics have an x squared as their largest degree. Okay? If that was x cubed, that would be a cubic.
Oh, okay.
And to be a cubic, you don't need every single degree. You just look at the largest degree. Well, that classifies the polynomial.
Okay.
So this is a 6th degree polynomial. How would I write it in standard form?
5p to the sixth minus 3p to the third minus 4.
That's it.
Cool.
If only all math was this simple, huh?
Seriously. Yeah. Alright, so now it says find the sum or difference.
Okay.
So this one's 3a plus 7, sorry. And then a minus plus a minus 1.
These, you just want to add or subtract like terms.
So it would be 4a minus 6?
4a plus 6.
Or plus 6, yeah.
Because we're combining a plus 7 with a negative 1.
Okay.
Okay?
Cool.
Now let's change this up slightly.
Okay.
And put a negative sign there.
Okay, so then it'd be 2a minus 6.
2a plus 8.
Plus 8. Oh, because it's a minus.
There you go. In other words, my first goal here, I don't need these parentheses on the left. They don't really do anything. I can erase those without affecting anything. Okay?
Okay.
But if I erase these parentheses, I've got to modify the sign of everything that's in the parentheses. In other words, I can get rid of these parentheses, but it changes this sign to negative because I got to distribute this negative to the A. And I got to distribute that negative to the -1, which turns it into that.
Okay.
So now you have 3a plus 7 minus a. Well, that's clearly 2a. And then plus 7 and plus 1 is 8.
Okay. Cool.
Okay.
Okay. Alright, so the next one is x squared plus 6x minus 5. And then plus parentheses 2x squared plus 15.
Now, whenever I've got a plus sign in front of those parentheses, I can immediately remove the parentheses without affecting anything.
Okay.
Like that.
Okay.
It's only when there's a negative sign that the negative has to be distributed to each term. But now I've removed all the parentheses. Now it's just combining like terms. So what do we have?
Okay. So let's see here.
What's x squared plus 2x squared?
Just 2x.
What's the coefficient in front of x squared?
1.
So now we have 1x squared plus 2x squared. How many x squareds do we have?
So it would be 2x to the 4th.
No. 3x squared.
To the 3rd. Okay. Oh, okay.
There's a way to think about this.
Okay.
First of all, if I had 3x squared plus 5x squared, x squared is like an apple. Think of that as an apple. Okay? And if I have 3 apples plus 5 apples, I got 8 apples. And an apple is x squared. Okay? So I can add like terms. Where people get confused is when they're multiplying. If I were to multiply those two numbers, then if I have, that would be 15, 3 times 5, x to the 4th. I am multiplying the same variable, which is x, you add the exponents. But addition and subtraction is completely different and a lot harder. If I'm adding these, then it's 8x squared. Notice that I can not add those two numbers. That is not x to the 5th. What this is x squared plus x cubed. In other words, you can't do anything. You cannot combine them. Okay, so addition and subtraction is very difficult. I can multiply all day long. Multiply, what's that equal to?
Then it'd be x. Would it be, because I know you have to divide, so. Okay,
the way to memorize this is that when you're multiplying same base, and in this case x is the base, different exponents, you add the exponents.
Okay.
You always do one level less mathematically. We are multiplying, so we are adding. If I had x to the 3rd divided by x squared,
then it'd be x to the 6th.
No.
I mean, sorry, x to the 1st.
Right. I'm dividing.
Yeah.
So I'm going to do subtraction. In other words, subtraction you can kind of think of as one level less than division. Just like addition is one level less than multiplication. Okay, and then the third important rule for dealing with exponents, same base. In other words, by same base, I mean if I'm doing this. What's that? 2 to what?
It'd be 2 to the 9th power.
Okay, good. Okay. So it doesn't matter whether it's x or some number that's the same. If it's the same base, then we're going to add the exponents. Now there's one other case where if I had x squared and then I exponentiate that again, What's that equal to?
X to the 6?
Yeah. In other words, notice we multiply the two numbers.
Yeah.
Multiplication is one level less than exponentiation, mathematically speaking. If you were going to say what comes below exponentiation, it's multiplication and then addition. Okay? So that's how you handle the three cases of same base. Okay? So if we are adding x squared to 2x squared, we start out with 3x squared. That goes on the far left always. You always put the highest degree polynomial on the left. What's next?
So it'd be 3x squared plus 6x plus 10?
Yeah.
Okay. Alright, awesome. So next it'd be find the product, so it'd be y minus 5, and then 3y plus 8.
Okay. How are we going to do this?
So it would be, so you're multiplying them, so it would be 3y squared. So 3y squared.
Have they taught you FOIL, Dylan?
Yeah, very briefly. I'm so confused on it.
Well, don't even think about FOIL. Think every term by every term.
Okay.
When I say every term by every term, I mean I'm going to multiply those two terms, and then I'm going to multiply that by that, then I'm going to multiply this by that, and then I'm going to multiply that by that. That's what FOIL is. The only thing that FOIL doesn't work well if you have three terms.
No.
But every term by every term does. In other words, if I have a plus b times x plus y and I add a third term to that, now just think of doing these as every term by every term. And keep it in a consistent methodology. In other words, by that, I'm going to say, okay, so that's the first term by the first term. And the way I do it is I always do, and then the first term by the second term, and then the first term by the third term. And then we go to the second. In other words, always work left to right. Now we're going to take b, multiply it by x, then we're going to take b, multiply it by y, and then we're going to take b, multiply it by z. So what you would get here would be ax plus ay plus az plus bx plus by plus bz.
Wow.
Okay? So FOIL doesn't do you any good when you have three terms on one side. But
no, it doesn't.
ET works regardless of how many terms. I could have 8 terms by 9 terms, and ET will get you to the answer. 2 terms is particularly easy. 2 terms, FOIL works. Notice that FOIL you should know what FOIL means.
Yeah.
It means first, outside, inside, and last. Well, let's go through that. First means that times that. Outside means that times that. Inside means that times that. And last means that times that. Notice that that's ET also.
Yeah.
So I'm not sure why they teach FOIL. They should teach ET, every term by every term.
Yeah.
And the only thing you want to not make a mistake on is missing one. In other words, the one advantage of FOIL is it tells you the pattern. We don't do this times this, and then this times that, and then this times this, and then this times that. That's, it's the same answer. You get the right answer. And that works fine if you're only dealing with 2 terms times 2 terms. But when you get to 3 terms times 3 terms, you better make sure you have your pattern down right, because otherwise you'll lose track of what you've multiplied and what you haven't.
Okay.
Okay?
All right. Cool.
So did we come up with an answer?
Not really.
What
So,
was the problem again?
yeah, it's y minus 5 and then 3y plus 8.
So what's our answer?
So it'd be 3y squared minus 40.
Minus what?
Minus 40.
No. Let's make sure we follow ET by ET.
So it'd be plus 8y.
There you go.
Oh, okay. And then... Oh, and then minus 15y. Minus 4.
There you go. Don't forget those middle terms.
Okay.
Okay?
So now, yeah.
If you want to know the number one problem missed in algebra, it's when people multiply these two together and they get y squared plus 1. Not correct. They're missing the two middle terms. There's a minus 1y there, and there's another minus 1y there. So this is equal to y squared minus 2y plus 1. Okay? You don't want to miss those middle terms. So always remember that ET by ET. You just have to cover all four bases there. In other words, the first time through, you did that one and you did this one. That's it. You didn't do this times that. Excuse me. You did do that. You didn't do this times that, and you didn't do this times that one.
Okay.
You do all four.
Okay.
And whether you call it FOIL or ET doesn't matter.
Yeah.
What I like about ET is as long as you know that it's every term by every term, it covers everything.
Okay. Yeah. Okay. Awesome. So now it says solve the system of linear equations. So this one's x squared plus 5x equals 0.
Okay.
So
I want you to solve this for x.
Yeah.
Okay.
Yeah.
How am I going to do that?
So first, could you do 5x is equal to 0?
No.
No.
What we have here is two things being added together that equals 0. In other words, I've got x squared plus 5x equals 0. That doesn't do me much good. I can't make much progress that way.
No.
The solution always lies in factoring these. Why? Because if I factor it, I'm going to have the product of two things equals 0. That's a whole different story. If I can get the product of two things equal to 0, if I have a times b equals 0, I know that one of those has to be true. You cannot produce 0 unless one of those pieces of the product is 0. In fact, if I have A times B times C times D times E equals 0, one of those letters has to be 0 by definition. Okay? Cool. So that's probably the most fundamental theorem of algebra, is that when you multiply things together and you get 0, one of them has to be 0. So the way we want to solve this is by factoring it. Notice that if I factor it into this, is that a proper factoring?
It is, yeah.
Okay. Now I've got the product of x times x plus 5 equals 0. Therefore, either x is 0 or x plus 5 is 0, which means x would equal minus 5. So there's my two solutions. And we
Oh,
almost
okay.
always have two solutions when we're dealing with a quadratic. This is a
Okay.
quadratic by definition because there's an x squared. That's what makes it a quadratic. You
Okay.
have a squared, it's a quadratic. Quadratics usually have two different solutions.
Okay.
Okay, if I give you this quadratic, x squared equals 4. That's a quadratic. I could say x squared minus 4 equals 0, right?
Yeah.
What's the two solutions?
So x and then parentheses. Wait.
Just take the square root of both sides.
So x equal to 2.
Plus or minus
Or
2.
2.
Those are my two solutions. Plus or minus 2. Now, the other way to do this problem is to subtract 4 from both sides.
Okay.
Now, how do you factor that? What's it called? That's called the difference of what?
The difference of 0.
Difference of perfect squares.
Oh, okay.
When you have the difference of perfect squares, by perfect squares, let's talk about it in terms of A and B.
Okay.
That's a perfect square. That's a perfect square. We've got the difference of them. We're subtracting them. This always factors into A minus B times A plus B.
Okay.
Okay? So, if I were to try to factor x squared minus 4, what would it factor into?
So if you were to do x squared minus 4, that factor in x minus 2. And then x plus 2.
Okay, now notice that if I solve it, I get x equal 2 or x equal minus 2.
Okay, cool.
So, in other words, if I do it kind of the hard way, which is to move the 4 to the left, and then factor it as difference of squares, I have no chance of making a mistake.
Okay.
If I do it the easy way and take the square root of both sides, 90% of my students will leave off the plus or minus.
Yeah.
Well, you'll lose points on a test.
Yeah,
If you solve this and you put x equal 2, you're going to lose at least half credit. Okay? Because that's not the answer. The answer is x equal plus or minus 2.
Okay.
Notice why. If x is minus 2 and you square minus 2, that's equal to plus 4.
Okay.
Or if x is 2 and you square it, that's equal to 4. So we can see that there should be two answers for that.
Yeah.
And you get them if you treat it as difference of perfect squares, and you also get them if you take the square root of both sides. Just try to remember that whenever you're solving equations and you're taking the square root of both sides, you get plus or minus.
Okay.
Even, you've had imaginary numbers or not? Okay. If I take the square root of both sides here, well, the left becomes x, the right becomes plus or minus 2i.
Okay.
Because the square root of minus 4 is 2i, and it's plus or minus because we were taking the square root of both sides of an equation, which always produces a plus or minus. It's kind of, what I try to tell everybody is that when you're taking the square root of both sides of an equation, always start your answer out with the words plus or minus. No matter what the answer is, it's plus or minus. If I've got x squared equal 47, then x equal, I don't know what it is, but it's plus or minus. Square root of 47.
Okay. Okay.
All right?
Cool. Okay.
Time for one more, if you have one more.
Yeah, let's see here. So it's p squared plus p, or it's plus 2p, minus 35.
Equals 0, or just factor that expression?
Just factor that expression.
Okay, doesn't really matter. They're both going to give us the same process. In other words, if it was equal to 0, the way we would solve it would be by factoring this expression. Then we would have two things times each other. Right?
Yeah.
That's why you always want to set a quadratic equal to 0. Is because once you can turn this into the product of two things, then we know how to solve it. Well, when they say just factor this, it's the same problem. It's just, it's not solving an equation, it's factoring an expression. What does this factor?
So this factors out to, let's see here. We could do...
Now, let's see. We had this conversation last time, I believe. You've learned the diamond method, or what they call the California method?
Yeah.
Or not?
Like the table method?
Yeah.
Yeah, we learned that.
Well, okay, go ahead. Apply it here.
So, yeah, let me see here. A times C, and then B equals 2. So... so... what could we do?
Here's the...
okay, so we could do X... No, you're good. So we could do P minus 7. And then P minus 5. Or P plus... Yeah, minus 5.
Is it minus?
Yeah, it's minus.
Well, what's going to happen when I multiply minus 7 times minus 5 as the fourth step of FOIL?
Oh, you get plus 35. So it'd be X plus 7 and then X minus 5.
There you go. Has to be that.
Okay.
Okay. Now,
Okay.
I don't want to confuse you, but I think my method's simpler.
Okay.
So let me just tell you my method, and you can use either one. But my method has 3 steps to it on a simple quadratic. And what I call a simple quadratic is one where this coefficient right there is 1. Okay? First thing I do is separate the p's. P squared has to be p times p.
Yes.
Second thing I do is determine both signs. Okay? The fact that that's a negative in front of the 35 means my signs have to be opposite. They can't both be positive, they can't both be negative.
No. Okay.
Now, once I'm at this stage, I'm looking for factors of 35 that subtract, because of that negative, to the number 2. Well, factors of 35, there's 7 and 5. 7 and 5 subtract to the number 2. Okay?
Cool.
Now the final step of my process is you put the bigger of those factors, the 7, with the sign of the middle term, which is plus. There's the sign of the middle term. It's plus, so I'm going to stick the 7 with the plus and the 5 with the minus, and I'm done.
Oh, okay. Cool.
Okay? That's the same thing you're doing with your method. It's no different. Okay, it may be structured a little different, they may define it a little different, but it's the same basic method. Okay, I just don't use a table, or I don't use that, or I don't use that, whatever. They've come up with all these sophisticated methods to teach people to factor, but I think that those methods confuse people more than help them.
Yeah, they can.
But it's also confusing if I teach you one method and your class teach you a different method. And I have found myself confusing students, not helping them by showing them my method. So I want to make sure I don't do that with you.
No, you're good.
As long as you can do it, I don't care what method you use. If you can't do it, then I got to try to help you with some method, and the only method I know is my method. I honestly, I don't like the other methods. I don't even know them.
Okay, yeah.
Because I don't ever use them.
Okay.
You only learn something by using it periodically.
Yeah.
It'd probably be better
Okay.
if I did learn. And I have a video on how to do it, so I could learn how to do it. But I think it's so obnoxiously complex that I prefer my method.
Okay, awesome.
Okay, Dill.
Awesome.
I will
All right, thank
let
you.
you go. I'll talk to you next time.
Sounds good. All right, thank
Bye-bye.
you. All right, bye.